consecutive terms of an exponential sequence GP are the second, third, and sixth terms of a linear sequence AP. Find the common ratio of the exponential sequence. This is a WAEC question. So in finding these questions, you have to consider the GP, the series in the GP, and the series in the AP. So therefore, what they are mentioned here is the first three consecutive terms of GP, which we have. A is one of the first. The second one is AR. The third one is AR squared. So its equivalent is equal to terms of AP. The terms of AP. So he said the three consecutive terms of an exponential sequence GP are the second, the third, and the sixth terms of linear sequence AP. So what is this second of AP? The second of AP will give you A plus D, and the third of AP will give you A plus 2D, and the sixth terms of AP will give you A plus 5D. So this is the interpretations of this question. So now you now try to equivalent it one by one to now say that A is equal to A plus D. We relate this as in equation 1. AR is equal to A plus 2D. We relate this as equation 2. We said to AR, not AR squared. We have AR squared, which is the third one, is equal to A plus 5D. This give you equation 3. So now, our question said that find the common ratios of the exponential sequence. How do we find the common ratio? This is where we need a little mathematical applications. So the first thing you are going to do, you said the equation 2 to be divided by equation 1, which we have AR to divide A is equal to A plus 2D to divide A plus D. So therefore, in this, let me write it clearly. The 2D, yeah, we have 2D. So now, before a cross multiplication can occur, there must be a 2 equal fraction. So now, you have to cross multiply this equation. Before you cross multiply, you divide this to be this. We have R is equal to A plus 2D over A plus D. So this is the values of the common ratio in one aspect. So we can represent this by maybe equation 4. Let's say equation 4. So now, but recall, I still remember that we still have AR squared, which is, so let's divide equation 3 by equation 2. You have to follow me clearly. You have to take your, so equation 3, which is AR squared over AR to divide, you see, from here, which is A plus 5D to divide A plus 2D. So we have A plus 5D to divide A plus 2D. So now, also, you recall that A will cancel A, R will cancel R. R also is also the same thing as A plus 5D over A plus 2D. Let's call this equation 5. So now, we have equation 4, we have equation 5. We have through with that. Let's equate the equation 4 and 5 together. So because Y, R is equal to R, R is equal to R. So let's equate the two equations together to have A plus 2D over A plus 2D over A plus D. A plus D is equal to A plus 5D over A plus 2D. So now, this is statement I held at the other time, that before you can apply an equality sign, there must be a equal fraction. Before you can apply a cross multiplication terms, which is this, we now cross multiply to have a plus 2d to multiply a plus 2d. It will also give you a plus d onto a plus 5d. So this calls for an expansion. So we need to expand at this part. So now a to multiply a, we have a squared. A to multiply 2d, we have plus 2ad. 2d to multiply a, we have plus 2ad. 2d to multiply 2d, we have plus 4d squared. So that is the first expansions of that. So which is equal to a times a give us a squared. A to multiply 5d, we have a plus 5ad. D to multiply a, we have plus ad. D to multiply 5d, we have plus 5d squared. So now let's add together to have a meaningful equation, which we have a squared plus 4ad plus 4d squared is equal to a squared plus 6ad plus 5d squared. So now let's collect the like terms in an equal signs, where we have the like terms a squared, ad, and d squared. So the first thing we are going to do is said a squared minus a squared, that is you equate that one, plus 4ad to minus 6ad, which will give you 5d squared minus 4d squared after we have equate. So this is the how to equate. Now recall that a squared minus a squared will surely turn to 0. This will turn to 0, we have no values. So therefore 4ad minus 6ad will give you minus 2ad, which is equal to, now 5d squared minus 4d squared will give you the d squared. So therefore, let's try to do something that's, let's divide all through by d. Let's divide all through by d. By the time we divide all through by d, we have a meaningful values that we have minus 2a is equal to, so by the time this divide d, we have d. So recalls that this value is the value of d. So d now, d give us, d is equal to minus 2a. So this is a very meaningful answer. So now, what are the values of our r the other time? Our r, one of them is equation 5, equation 4, and 5. You can pick any of the equation. Let's pick equation 4, which is a plus 2d to divide a plus d. A plus 2d to divide a plus d. So therefore, our r is equal to a plus 2d to divide a plus d. But recall, we have able to get the value of d, whereby d is equal to a plus 2 onto minus 2a. That's the values of d. That's the values of d. So a plus d, we have a plus, what's the value of our d? Minus 2a. So this is how we are going to apply the polarity multiplications, which is equal to a minus 4a is equal to a minus 2a. So therefore, we have a minus 3a over minus a. So recall that the value of our r, the minus we cancel minus, a we cancel a, which is equal to 3. So therefore, from the questions, he said, find the common ratios of the exponential sequence. So the common ratio now is equal to 3. The common ratio is 3. So this is the final answer. Don't forget to like this video and share this video. Thanks for watching.